Hello students, I welcome you to this session of Python programming. In today's session, we'll be discussing the bitwise operators from where we left it in the previous video. And we discussed that there are bitwise operators as bitwise AND represented by ampersand, bitwise OR represented with a pipe symbol, bitwise exclusive OR represented with the caret symbol, bitwise NOT with the tilde symbol, and bitwise left shift and right shift operators. So just a quick recap with the bitwise AND, OR, NOT and caret, and then we can focus on the shift operators. So let us begin Python interpreter session here for you to, just to have a recap of the bitwise operators that we discussed in the previous videos so that we are connected with this topic. So let's suppose that we have taken a variable a as 4. So in binary it is represented as 100. 0b represents the binary, so 100 is the binary a. And if we take b equal to say 9, okay, b as 9 and its binary would be 1001. So we can take it as this. So if we have an AND of this, it results in 0 because no corresponding bits are having both the values as 1. So here if it is 0 here, then here it is 1. So if you AND them, the answer is 0. So ultimately the answer is 0 here. And if we do the OR operation with them, okay, then we get 13 as the answer. So in bitwise OR operation, the individual bits, the corresponding bits, when they are paired together, if even if one of them is having a value 1, the resultant is 1, and then we calculate the final answer. And let me now discuss the bitwise exclusive OR with you. So here, if we see the bitwise exclusive OR of A and B, then we would see the answer here is 13. The idea behind bitwise exclusive OR would be to see here that each bit of the output is the same as the corresponding bit in X if that bit is Y in 0, and it's the complement of the bit in X if that bit is in Y is 1. I would tell you an easier way for this. In bitwise exclusive OR, you can add up the bits. Okay, you can add up the bits, and if the sum of the bits is odd, your resultant bit would be 1. I repeat, in bitwise exclusive OR, you add up the individual bits. If the addition is odd, your resultant bit is 1. If the sum is even, your resultant bit is 0. That is how you can work with bitwise exclusive operator. Another note on here, while you were ANDing, here in X and Y, you multiply both the bits. If the output is 1, if after multiplying the result is 1, the resultant bit is also 1. And here in OR, an easier way to do it would be to add the bits, and if the answer is 0, the output is also 0. If the answer is 1, then the output is also 1. Okay, that is an easier way of remembering. Now let's see what this bitwise NOT does. Okay, bitwise NOT represented as tilde X. It returns the complement of X, that is the number you get by switching each one for a 0 and each 0 for a 1. An easier way to remember this is simply as that bitwise NOT X would be equal to minus X minus 1. Okay, so let's see this bitwise NOT. So if we have a variable a is equal to 6, okay, and if I perform this would be minus 7. So remember so not a is minus a minus 1. So minus a is minus 6 and minus 6 minus 1 is minus 7. An easier way to remember bitwise NOT. Okay. Then I think we can now discuss more important operators, that is bitwise left shift and right shift. So just see how this left shift works. It is represented as this X to less than symbol Y. Now it returns X with the bits shifted to the left by Y places. Okay, so in left shift, you shift the bits towards the left, and the number of bits that you shift towards the left, as many zeros are added on the right side. Okay, And a shorter way of remembering this is same as multiplying x by 2 raised to power y. Okay, so we'll discuss one operator at a time. I'm first discussing with you the left shift operator, in which it means that x left shift y, where y is the number of bits to be shifted. So it returns x with the bits shifted to the left by y places, and the new bits on the right hand side are zeros. So as many bits you shift towards the left, as many zeros you add to the right, and this is same as multiplying x by 2 raised to power y. Okay, so let me just open up another document for you to explain this to you. So I've taken up an example for you. Let's first discuss the left shift operator. Now suppose A is 4. Okay, so its binary equivalent is 0 1 0 0. Okay, this is its binary equivalent. So let me now left shift A by 2 bits. A 2 less than sign 2 means shift the bits of A left by 2 places and add 2 zeros on the right. So it becomes this. I hope it's clear. Let me just demonstrate it to you. So we had, this is the value of A. Okay, so if you shift these two bits towards left, okay, that means you need to add 2 zeros here. Okay, no, towards right, yeah, towards right, I'm sorry, towards right, like this. So if you are shifting it towards left, so 2 zeros are added to the right, and this number, this binary number is equivalent to a decimal equivalent of 16. Now you see the other thing that we discussed, that A left shift 2 means multiplying A by 2 raised to power 2. You can see it here, that x left shift y means multiplying x by 2 raised to power y. Okay, so here the same thing is there. So if you multiply A by 2 raised to power 2, 2 raised to power 2 is 4 and A is also 4, so 4 into 4, the answer is 16. Okay, I'll show this example to you in the Python interpreter also. Let's take another example. Let's suppose that A is 12 and its binary, so its binary equivalent is this 1100. Now shifting A to left by 2 bit means that shift the bits of A left by 2. So we move this 1 towards left on this side and zeros are added here. Okay, so I've done it for you. So it was 1100, so 2 zeros are added to the right. Now this number is equivalent to 48. Okay, you see here this 0 is 2 raised to power 0, this 0 is 2 raised to power 1, this 0 is 2 raised to power 2, this is 2 raised to power 3, this 1 is 2 raised to power 4. So this is 2 raised to power 4 into 1, 16. This is 2 raised to power 5, that is 32. So 32 plus 16, the answer is 48. Okay, and this is same as multiplying the result by 2 raised to power 2. So 2 raised to power 2 is 4 and multiply 12 by 4, the answer is 48. Okay, so let's now see this in our interpreter. Let's take A as 4 and I'm going to left shift A by 2. So we get the answer as 16 as we saw here in the first example. Let's take the second example. Take A as 12 and left shifted by 2 bits. Okay, so let's take A as 12 and left shifted by 2 bits. So the answer is 48. That is how the shift operators work. Okay, so you can work out examples on this. When I send you a problem sheet, I'll definitely send you examples based on these bitwise operators also. So meanwhile, you can just watch this video and practice some examples on your own. Okay, let's now move to this the right shift. So right shift is just the opposite of left shift. Here the bits are shifted to the right by y places and zeros are added on the left hand side. Just the reverse of this. And this is the same as dividing the x by 2 raised to power y. Here in left shift it was multiplying x by 2 raised to power y. Here it is dividing x by 2 raised to power y. So let's take the example for the right shift operators now. So same example, suppose A is equal to 4. So its binary equivalent is 0 1 0 0. So if I shift these towards left, 2 bits towards left, then these 2 zeros they vanish and I have to add 2 zeros on the left. Okay, when I'm right shifting it, it goes 2 bits towards right, so these two zeros go and two zeros are added on the left, so it becomes 0001, so that is 1, and it is same as dividing a by 2 raised to power 2. So a is 4, so when you divide it by 2 raised to power 2, that is 4, the answer is 1. Okay. Similarly, here let's take an example of a is equal to 12, its binary equivalent is 1100. So right shifting it means when we shift it towards the right, these two zeros they vanish and two zeros are added to the left, so it becomes 0011, which is equivalent in decimal to 3. So we had the number 12, when we right shift it by 2 bits, we get the decimal equivalent as 3, and it's the same by dividing 12 by 2 raised to power 2, so we get the answer as 3. Let us now go to the Python interpreter to check this. So if we have a is equal to 4 here, and I now right shift a by 2 bits, the answer is 1, and if a is 12 and I right shift it by 2 bits, the answer is 3, so as we discussed. Okay, so let us now go back to our presentation and discuss how these operators are at in terms of hierarchy. So the not, bitwise not, is at the top of the hierarchy. In among these operators, bitwise not is at the top. After that comes the shift operators, the left and right shift, they are at the same level, so their association is left to right. And then comes bitwise and, after that bitwise exclusive or, and then bitwise or. So we have got 5 distinct levels of hierarchy here, with bitwise not at the top and bitwise or at the bottom, and these two operators are at the same level, so among them the association is from left to right. Okay, so let me now just work out a combined example for these operators. Okay, so let me take you to a Python session on blank screen. Okay, let me start a Python session again. Let's see how you can answer this, how to work about these operators. So I'll take the shift and the bitwise not operator for the example. So bitwise not, you remember, just negates the value. A 0 is converted to 1 and a 1 is created converted to a 0. So we are just getting a delay in our, we got 2 windows now. So let's say I've got a variable a is equal to -5. Okay, if I take an expression here, this, what would be the answer? Which operator would be performed first? So obviously bitwise not would be performed first. So bitwise this not would result in a is equal to -5. So remember, minus a minus 1 is the answer. So it is minus a means minus minus 5, so plus 5. So plus 5 and minus 1 is plus 4. And 4 left shift 2 is 16, as we saw in our example. Okay, so I can again show it in 2 parts to you. A is equal to -5 when I do, and if I do a not a, the answer is 4. And then if for 4 I do a left shift 2, that is 16. So combine these 2 steps here when you have a is equal to -5 and this here. Okay, so first this bitwise not is performed, which converts results in a value of 4, and then 4 left shift 2 results in the value as 16. So if I make it right shift, the value would be 1. So this is like what we discussed in our examples. So just to have a quick recap of these operators with you all, bitwise and, or, bitwise exclusive or, not, the left shift and right shift, these are the levels of hierarchy. Bitwise not is at the top, and bitwise left and right shift follows them, then and then exclusive or, and then or. Okay, and in my next video with you guys, I'll be discussing the remaining operators in Python, and I'll give you a complete hierarchy list of all the operators, like all the operators, how they are associated with them. We have seen them at individual levels, like arithmetic operators, we have seen the levels of hierarchy. Bitwise operators, we have seen levels of hierarchy. Relational operators, we have seen levels of hierarchy. Now in my next video, I'll just finish this topic of operators and will give you a comprehensive hierarchy level of all the operators which are there in Python. So till then, thank you, keep watching.